Everybody settled again? I hope you had a very nice break and some of that lovely cake. I had 2 slices, great stuff. Okay, so while the notable absentees at the moment are the jurors, because they're off deliberating on the various awards that will be given out after this particular talk. We have, as I've just said, an aforementioned talk. And it's going to be given by Professor Geert-Jan Dinant from the Maastricht University, and he'll be speaking about biosensors change healthcare. Thank you.
Thank you very much. I understand the microphone works. It does, doesn't it? Yeah. I was just wondering, before we make a start, 2 things. I changed the title a little bit. Any idea what the change is? Question mark, that's 1, and 2. It will be a bit interactive the next few minutes. This is the first question. And number 2, second change. Brackets. It may illustrate what we will be talking about a couple of, let's say, the next few minutes, because not everything yet, at least in medicine, that's my job, is fully clear yet. Things are changing all the time. You kind of illustrated it as well, your students, earlier today. And the second thing is that I was wondering why you, as an organization, invited me to give you a particular presentation. Why is that an interesting question? Because when if you would take my job, family medicine, general practice, it's 2 titles for the same job in this country, like in a few other countries as well. I'm not the only, let's say, medical doctor doing this. There are, at least in this country, any idea how many GPs you will find? On average? Any idea? Yeah, it's almost 10. Well, in fact, it's 10 or 11,000. Of those, at least 8,000 will see patients. And they kind of cover something like 5,000 to 6,000 FTE. So that's a large group. But it still didn't answer my question, why was I invited here? And then I kept wondering and wondering. And then I think I found the answer maybe just last week. When I realized that I was born in this city. So that's secret number 1 for today, that I just shared with you. I was born in this city, and it took place 60 years ago, so that's my age. That's the second secret. And I was not just born in this city, but I also went to school. So I first went to kindergarten, which is the only German word used worldwide, by the way. Then I went to elementary school. And I still remember, I think it was in class 2 or something, that I was in elementary school. There was this blackboard, of course. There was a teacher standing here or doing his things. It's still the same, I think. And there was this blackboard, and from the board there came a wire. This is a technical university. There came a wire, and until somewhere here, and there was, at the end of the wire there was a button. And if you would press the button, then the board would go up. I'm talking about the early 60s now. And that was bloody innovative. Not any school in the whole world would have such a machine. So it may illustrate how things change in 60 years. Well, 50 years, in fact. And if you would be, let's say, a good pupil, a good boy, then the teacher would allow you to press that same button once or twice a year. And it felt like sending a rocket to the moon. And the only reason that this school was located in this city in Eindhoven was because there was a particular company behind this adventure. And you already know which company I mean now. Of course. And in those days, they didn't just, let's say, own those machines, but they owned the complete city, the entire city. Meaning that every house would be at least part in the hands of Philips, a company again. In fact, every stone or brick would be owned by Philips. And I can tell you that's history again, because that completely changed. But in those days, Eindhoven was Philips, nothing else. Well, and the church, of course. I think it's still the same, the church, I mean. And then I went to high school. High school is not far from here. You can see it. If you would stand on the roof, it's still there. Not far from here. And I just discovered recently that this particular high school now has a kind of second title, and that's Brainport School. And they should have told me 50 years ago, I think, because that might have prevented me from going to medical school. Whereas going here, because the university was already here, technical university. Anyway, so I went to medical school, which made I still remember my teacher in mathematics very relaxed, because he was used to tell every boy or girl in his class who didn't understand that very much about mathematics, and that included me, please go study medicine. In his view, it was the worst thing you could do in life, so that's what I did. And then I completed, and I went for the specialist training in family medicine, and I completed that as well. And then I found a job at Maastricht University, again, not too far away from here. And for, let's say, learning a little bit more about research, because in those days medical school had nothing to do with research. Nothing, absolutely nothing. To some extent, it's still the same. That's not good news. So I entered the other university in Maastricht, and my supervisor there told me on day one, I still remember, why don't you do something with this? What is this? Any idea? Blood cells, very well, you get a prize. Yeah. Which ones? The red ones, very good. Yeah, applause. So here they are, and they're, let's say, in tubes, as you can see, more or less. Now, the funny thing with blood cells, there are quite a few funny things with blood cells. Well, one of the funny things is that, like every cell, I think, tends to fall down. If you do nothing, they tend to fall down. They drop. You agree? Say yes. Okay, you agree. And let's say the dark red ones drop down already, and the light red ones are still, let's say, considering to drop. Or they didn't drop, or a better, let's say, division would be that these are still the red blood cells, and the other, let's say, half of the column or 2/3 of the column is what? Sorry? Pink? Yeah, you mean the color. Very well. But what would it illustrate? Plasma, probably, something like that. Eh? So there are no red blood cells there anymore. Now, this, let's say, dropping down, this falling down, usually takes place with a particular speed, of course. Not very interesting, but it's the way it is. And the speed will increase once you, let's say, bring these blood cells together, once you kind of connect them to each other. So it's not a singular red blood cell anymore, but it's a kind of, let's say, group of blood cells. And how do you link them together? By buying a particular glue and then do like this, and then it happens. That's not what's happening in the body. The body is more clever because it may produce a particular protein that makes the red blood cells connect together. Any idea what the name is of this particular protein? It's a group of proteins. I'm teaching a bit medicine now. Could be, name of the group, acute phase proteins. Acute phase proteins. What are they doing, those proteins? Any idea? Yeah, but what do they illustrate or represent? First year medical school. They illustrate that I'm ill. Suffering from what? Sorry? Could be indeed, but let's say more likely it will illustrate that I'm suffering not from thrombosis, that's what you said, thanks, by the way, but from some kind of an infectious disease. Or from some kind of an, well, let's, as an example, take arthritis as an example, which is not an infectious disease, it's an inflammation, so it's inflammation and infection. So, if that's the case, and indeed it is, then those acute phase proteins might, me as a doctor, help me to measure or to find out whether or not a particular patient is suffering from an infectious disease or from an inflammation after the patient presented her or himself to me with particular complaints. So I can measure this. And that, let's say, measurement carries a certain name, and that's the erythrocyte sedimentation rate, ESR, erythrocyte sedimentation rate, which looks like this. It's rather old-fashioned, I can tell you. So what I'm doing now is partly talking about history. But some of you might still remember this particular device or test. It used to be in every doctor's office for a very long time. It was found out in 1890, somewhere there, so that's pretty long ago. And until a few years ago, it was still a very popular test. So what I would do as a doctor is I see a patient and he or she is complaining of, let's say, fever or particular pains, and I want to know whether or not is the patient suffering from an infectious disease, and I would take a blood sample, put it in a tube, and then wait for how long? Any idea? It's not a quick test. It takes 1 hour. So I need to wait for 1 hour for the blood to do its job, for the erythrocytes to fall down, and I measure it there, as you can see, on that particular scale, and then I have a kind of measure or test or whatever, test result for infectious disease, yes or no. Now, let's say, from a medical point of view, it's not a new story that I'm telling you now. A little bit new might be that there is a second way to help those erythrocytes to drop down. And that's not, let's say, infectious disease, but it's something else, and I'm going to show you that because I brought it. I brought such a tube. I remember that one of your students showed me something very small earlier today. Well, this is the tube I'm talking about. It's a bit longer, still very thin. So the blood goes in there. So this is one of those tubes. And what I can do is, if I want to, let's say, help the erythrocytes to drop down a little bit quicker, that I take it like this and do this. Tremble or shake the whole thing. Very easy, eh? Physics. Just this. Has nothing to do with medicine. But we thought it's relevant to understand or relevant to realize, because doctors might do this without knowing that they're doing this. And indeed they did. Because what did they do in those days? Not anymore, but what did they do? They might put the device on top of a fridge. Doctors are no technicians. Eh? They don't know nothing about reliability. They don't even, let's say, have the proper definition of reliability in their mind. And that includes medical students. So there's still a way to go. Anyway, so they put it on the fridge. Why? Because their laboratory is usually very small. There's no space. So there's no other option than putting it there. So that's what I did. And then, as you can imagine, if you open the door and you wait a little while, indeed this fridge is in our department. It's not from Philips, I'm sorry. And you open the door, so you see what we eat and drink in our department. That's for, let's say, later to talk about. And you wait a little while, then the machine will start cooling. It goes a little bit like this. Not that bad anymore today, but still, it does. And then the blood will drop more quickly. Indeed, it did. And so my first experiment was finding out whether or not this takes indeed place. The answer was yes. And then whether or not it's clinically relevant. And the answer again was yes. And then I wrote my first manuscript on this particular story in Dutch, later also in English, because I thought, well, that's maybe interesting for, let's say, the medical population, medical doctors to see and to read. And it was right away accepted for publication in the Dutch Journal of Medicine, Nederlands Tijdschrift Geneeskunde in Dutch, which still surprises me until today, because even the referees didn't have any comments. They were like, something like that. And then I thought, well, if publishing is so easy, then probably the next thing I will get is a Nobel Prize. Because it's, I mean, everybody told me it's so difficult. It just happens. That's what I thought. Well, I never got that prize. But still, I'm still proud of this publication, and we did a few more studies. And here you see where this particular picture comes from. It's the cover of my PhD thesis that I defended in '91, so that's 25 years ago, on the, let's say, diagnostic value of the erythrocyte sedimentation rate. So there were a few more studies done, and we found out that it's still a useful test, in short. I'm not going to repeat the whole book. But you remember it took time to do this test. How long again? 1 hour. You have a good memory. That's too long. Because the average time we have for, let's say, finding out, and then I'm talking about general practice now, family medicine, for finding out what a patient has or is suffering from, plus presenting a treatment, plus talking the whole thing over, will be how many minutes in this country? Any idea? 10, well, we found out it's 11, 10 or 11, so that's very short. That's much shorter than 1 hour. It might be a little longer in the neighboring countries, but not that much longer. So that's very short. In the meantime, we learned from this particular reliability study that research, first of all, is fun, but you already know because you showed it to me and to the public earlier today. And that sometimes, let's say, the best way to do research, whether or not it's technically oriented, is keep it simple. And I found out that's not always very costly. The study I did with the shaking fridge, you remember, costed me something like 100 guilders, which would be by now something like, how many euros? 45 or something, so it's very cheap. Don't be afraid. People told me, I still remember, that this is going to be an unpublishable study because it's about nothing. They proved to be wrong. And that's the one but final bullet. We kind of illustrated, that's what I already told you, that you should not trust devices, technical instruments into doctors' hands, unless they are properly trained. The majority of the medical doctors is not properly trained for handling devices. So once you go to the big world after today, and then try to sell or bring into the market the devices that you made, then remember this one. Doctors are clumsy. They can talk and they can diagnose, but they know nothing about the technical world. So that's an extra job for you for the next few years. But this is what I said a few minutes ago. We need a faster test. Now, that faster test was quickly there, and it's in the middle of this particular picture. Any idea what the test is doing? It's the gray one here. Ever seen it? Comes from Scandinavia. So where the Swedish and the Danish colleagues? There they are. It starts with a C. This machine is measuring C-reactive protein, which is one of the acute phase proteins. In fact, it's one of the most important. And this machine is much quicker. It takes no more than, let's say, 2 or 3 minutes to find out whether or not CRP is elevated. And it's measuring the same thing as ESR, but even its diagnostic value is better than ESR. So that was very good news. And we did a series of studies to find out whether or not this really means something, this particular machine. Now, what I summarize on this slide took us about 10 years to find out. Because step number 1 was, and it's even not here, was finding out, is it a reliable machine? It was. So that was good news. Then we wanted to know, does it not just, let's say, help me to diagnose a particular disease, but does it also help me to exclude the presence of a particular disease? Because don't forget that in medicine, the most important thing we do, and that includes all doctors, is first of all excluding, if possible, that a particular patient is suffering from an, let's say, life-threatening disease, like an acute coronary syndrome, like a pneumonia, severe one, like a cancer, and so on. And after I excluded, as a doctor, that particular issue, then the next step will be to find out what he does have, the patient. Not the other way around. So machines must help me, as a doctor, machines must help me to exclude problems. And CRP did. We proved that CRP helps me to exclude the presence of a pneumonia in patients presenting with particular symptoms, which is very helpful because pneumonia is the only respiratory tract infection for which antibiotics are needed. And we found out that not just here, because let's say, well, compared internationally, we're not that bad in prescribing antibiotics in the Netherlands, but still it's on a relatively high level. And you all remember what a big problem with too many antibiotics will be, namely antibiotic resistance. So we get new diseases and they will kill you. So we as doctors must do better, that's what we told ourselves, in terms of diminishing the prescription rate of antibiotics that are not needed for those particular patients. And CRP does. And so the second bullet saying that it's a test treatment study, but that's more or less a term that you might use for what I just said. Now number 3, it goes a bit further than just the world of techniques, because we have this test and it does work and it does help. But doctors are used to talk. Their primary job is to think and talk. Not to test, not to make devices, not to handle devices, test and talk and think. Those are the 3 most important jobs we have. So I can do the CRP test, but if I don't tell a bloody good story to the patient, then it won't help at all. Then I better don't do this test. So the story that I'm used to tell to my patients, as an example, when they present and they say, well, dear doctor, I'm coughing now for 3-4 weeks, and I want you to help me with an antibiotic because then it will finally stop, is that I examine the patient, and then I tell the patient that, well, the best thing we can do now is this excellent, wonderful, recently developed from Eindhoven, etc., test called CRP, but you may forget the name, and it will take no more than 2-3 minutes, and then I will know whether or not you need antibiotics. And then, let's say before ordering a test, I probably already know that the patient doesn't need any antibiotics, and the test is going to help me to prove this. And the patient goes home and he says, well, that's a bloody good doctor, because he has this particular handheld machine almost, and that's telling me whether or not I need antibiotics. I've never seen such a good doctor. That's the talking and psychology part of medicine, which is much bigger than the technical part. So that's the talking thing. And we proved that it does indeed reduce antibiotic prescriptions. And we also proved or found out that all medical doctors who were involved in that study, and by now all GPs in the whole country, were, let's say, very happy with this development. They really felt, let's say, like having made a big step forward. And we kind of, let's say, succeeded in implementing the whole thing in the medical world, at least in primary care in this country, but also in a few surrounding countries. So it's altogether was a pretty good story. I'm still happy about that. One of the jury members, by the way, is one of the co-authors of this article. So he was one of the researchers here, Rogier Hofstake. And it was published in a British Medical Journal, which is not really a bad journal, I can tell you, in particular for us, as non-native speakers. And that was a couple of years ago. And we got a prize for that achievement. You see the whole team here. Nice picture. We got a prize because it was the one but best article published in a general medical journal worldwide that year. So did the test change health? Or did it change health care? What would you say? CRP now. Who goes for health? Nobody. Who goes for health care? So why not health?
I think you can change health because if patients are less ill because they're not resistant anymore, it's changing health.
Yeah, so if resistance to antibiotics is also reduced, that's what you're saying, then you might conclude that it does indeed change health of the population. I agree. Any other reason? Or argument against? Well, that's more or less the conclusion we draw. So we said it did change, must be on the next slide. Yeah, it did change health care because today not any primary care medical doctor in this country will wonder anymore whether or not he should use this particular test. So it really changed health care. Just this one single test, which is a biomarker, biosensor you could say. Did it change health? We don't know yet. We still need to find out whether or not it does, let's say, indeed reduce antibiotic resistance. We don't know yet. And it will be very difficult to investigate, because if we really want to know, we probably need to do a kind of clinical trial where we divide the world in two. And we say in one half of the world we will, let's say, include the CRP point of care test in medicine, and the other part gets some kind of fake machine. Placebo, something, whatever, or just nothing. And then see the difference. How many years does it take to, let's say, develop antibiotic resistance? Any idea? It's more than a week. Probably a few years. So that study will cost many, many millions. Any idea who will pay for it? Because we don't have that money, of course. Nobody will pay for it. Because nobody profits. Except governments. But they stay there for no long enough 4 years. So it will never happen, that particular study. So we just don't know. We just have to guess. But I hope that it, let's say, at least did help. Okay, so how does the story that I told you until now more or less relate to creatinine? Because that's what you were talking about earlier today and later today. And that's what you, let's say, put all your effort on over the past few months. Well, as some of you already said, this, let's say, creatinine point-of-care test, biosensor, should, like all, let's say, comparable tests, be an easy one, a fast one, and a reliable one. What does it mean in the hands of doctors? Remember, they're no technicians, and they're very clumsy. So usually I tell industries, and that might include you, I tell industries, make me a machine, and it has only 3 things. It has a hole, one hole. It has one button, and it has one screen. And the hole is meant for? How does it work then? Why a hole? Cartridge or? Finger. So I'm a patient now. I put my finger in the machine's hole from my doctor. Then the nurse presses the button. Not 2 buttons, just one. There's no choice. And the screen tells me in 3 minutes it's elevated or not. Plus the number, of course. That's all. That's the most perfect machine. Then it should have a kind of standalone predictive value. Like the creatinine, as you, well, probably found out when you talked about the test with, let's say, experts in the field. Does it really tell you, let's say, a particular medical condition or the future of a particular patient? To some extent it does indeed. I do the test myself, of course, in quite a few patients. But it's very difficult to draw a conclusion just on the basis of this one test. Because the test is just a little part of a complete patient. So you need a much bigger story, and that's the doctor stuff. But still, if you do use it as a standalone test, then preferably it does tell you something. Does it steer treatment? What's the treatment of, let's say, one of you talked earlier today about, let's say, diagnosing horses or other animals in the hands of veterinarians for this particular kidney diseases, which is a wonderful story, of course. But then what would the vet do with a particular horse suffering from a kidney disease? I still don't know the particular medicine that you could give. I'm not a veterinarian, but still. Even for, let's say, for people like us, it's very difficult to make a choice. Otherwise, than following a diet. So does it steer treatment? Does it impact prognosis? Does it tell me something about how the condition will be in 2 or 3 or 5 years after today? Maybe it does, but we still don't know. And then here, when it comes to the kidney diseases, does your creatinine test in the end prevent those rising numbers of organ transplantations, kidney transplantations? That's a study that still needs to be done. And once you found out, I can tell you, you will get a prize, because it will be a worldwide famous study, I can assure you. Maybe the Kidney Foundation in Holland can pay for this. They're in the room, isn't it? And number 5, or number 6, very important, and I'm going to finish there. Remember that devices are well, you all know, they're, let's say, part of our life now, which is good. Because not for nothing they're developed. They're much more clever than they would be, let's say, 50 years ago with the tubes in which the erythrocytes drop down, because that's for a museum now. And they can measure much, much more than they could, let's say, years ago. But if doctors and patients don't feel happy, there's a big problem to solve. They must go home like... They go home and they tell their spouse at dinner, listen to me, what happened. There was a particular student from Denmark or Sweden, I forgot. And he came to me and he told this story about a new point of care test and is measuring how your kidneys are doing. I was waiting for the test for 25 years and now it's there. I'm so happy. I'm going to use it tomorrow. Then you did a good job. And then I would say that you really served medicine, healthcare, health, and people. So that's what I would like to finish my story. Thank you very much.
Thank you for the very, very interesting talk. We have a couple of moments while we wait on the jury. So does anybody have any questions for Gert on this very interesting topic he just spoke about? Anybody? Yes?
What should the target molecule for next year be?
The target what?
Target molecule for next year.
The target bullet. Molecule. That's a tricky question. You know, my job is treating people, not molecules. So I'm afraid you're asking yourself. But I can tell you what, from a medical point of view, the big issues are. When it comes to diagnosing, let's start with diagnosing and not treating, because that's let's say, it's second world. When it comes to diagnosing, then I think there are 5 big areas where we need to make steps. And they're, let's say, in different ways, by the way. Number 1, cardiovascular diseases. We are still too slow. Number 2, infectious diseases. We still don't have a proper test for TB, tuberculosis. We still don't have a proper test for viral pneumonias. It's still not there. It's very stupid. Number 3, mental health. We still don't know what the patient is suffering from. We go to this book and we tell ourselves, as doctors, we tell ourselves, well, on the basis of these particular symptoms, you probably have a depression. It's like in the Middle Ages. Nothing changed between there and now, nothing. Number 4, locomotor system. We still don't know, when I'm presenting with a painful knee, and you're a doctor now, we still don't know how you find out why it's the meniscus or something else. Imaging, that's the word. Imaging is still very old-fashioned when it comes to dealing with the locomotor system. And number 5 is the combination of diseases, because by now people get much older than they would get long ago. So they have time to develop not just one disease, but 2, 3, or 5. That's my job now, finding out and treating and dealing with people who, let's say, present with not just one disease, but 2, 3, 4, 5. Plus, we don't know the background of these combinations. So the whole autoimmune system is still like a big black box. And we really don't know where to, let's say, find out what the triggers are, what the molecules are. So I will be very happy if you can tell me next year about these molecules, because then, then together we can make a big step.
Okay, so at that, we will thank once again Professor Gert Jansen for a very interesting talk. And I see now that the entire jury has just returned, and hopefully there wasn't too much tough debates, or maybe there was, in terms of some of the awards. Now, before we find out who has won exactly which award, one of the jury members is going to give us a short summary or short talk. So I'd like to invite Dr. Rogier Hopstaken onto the stage to give us a short presentation.
SensUS is organized by students. Isn't it amazing what they have done? It's really, I think it's worthwhile to have a cheer and a big applause for them. For those who don't know, the people in red shirts, chaired by Luc Martin. There's thanks a lot for your great organization. And of course, I would like to thank, before we start the ceremony, the founder of SensUS, Professor Menno Prins. And what about those pitches, those presentations today? Weren't they amazing? I would like to have an applause for Crea Senza. Sense Up. IC Senses. Creative 9. And finally Test. This was the test. Are your hands warm now? I think yes. So let's continue. Well, the jury of SensUS, they're all seated there, is very proud to announce the winning teams of the awards. But before that, we cannot stress enough that you have already won. All those participants working together in multidisciplinary teams started only 9 months ago to build this biosensors. It's amazing what you have achieved, all of you. But of course, I'm a family physician. I would like to know what can be used by our patients tomorrow. So I think there's a lot of responsibility on your shoulders to make these devices work for daily patient care. And that's the next challenge for you. And I'm sure we will get to that. And it's needed. And as you can see already in this picture, I see a vulnerable family, patients who have scars on their souls, scars on their life, on their bodies, and they are worried about their child. These are the patients family physicians meet all day, and often they're just worried and you don't have to do anything. In a certain percentage of time, you need to diagnose them very well and take time to do that. And we work out quite well, but in some cases, it's very hard to diagnose the right patient. And yes, for example, when diagnosing pneumonia, sometimes you can it's like this picture, because your stethoscope will not help you in all times. Even an X-ray won't help you in all times. And of course, it's not rapid. So I would like you to meet one of my patients. He experienced one of those successful devices which are now there in at least primary care in the Netherlands, but also in Scandinavian countries. I think the sound is a bit soft, but you can read it in English. And here he is.
En toen heeft hij met het apparaatje wat hij heeft, het is een wonderlijk apparaatje, hij prikt je vinger. En duwt het in een, ik noem het dan maar even, een apparaatje. En na 3 minuten weet hij of jij een longontsteking hebt. Of iets anders. Nou, ik stond zo te kijken natuurlijk, hè.
And this is what happens, and this is what surprised the doctors I've met. And during, we talked through the whole country and meet a lot of doctors. And they were very reluctant to start using those devices. But when they started and they saw how the patients reacted on it, they were really very enthusiastic. And they asked me now, when is the next thing coming? We need, for example, a creatinine analyzer, which is good, cheap, accurate. And of course, we saw a lot of examples of promising developments this morning. But if you look right now, at this moment, there's still a lot to do. Okay, I shouldn't go start a presentation, so I will quit and go on with what we need to do as a jury. Well, the jury has judged and decided on 3 of the 4 awards. You know that: an Analytical Performance Award, the Creativity Award, the Translational Potential Award. And the Public Inspiration Award has been decided by you and the teams and the contestants. So what did we do? We talked a lot yesterday already with all the teams and the team members and witnessed all those tests being performed yesterday. So after that, we've discussed general issues preventing us to vote properly. And after that, we voted and ranked all the teams individually. And afterwards, we had some final discussion yesterday. Today, of course, we had all those pitches and again discussed this last half an hour on the final results for all those prizes, awards. So, this is the moment, I think. But I won't do it myself. So I would like now to ask Professor Tony Kaas to introduce and announce the winner of the first award, the Analytical Performance Award.
Thank you. So it gives me great pleasure to be able to announce the winners of the Analytical Performance Award. The decision was based upon yesterday's testing schedule. So each of the teams was presented with samples of serum containing creatinine, and they had to use their devices to measure the concentration, and then the result that they got was compared to the actual value of the creatinine in the sample. To give the competition a little bit of edge, the teams got their samples at an increasing frequency. So the first time they had 15 minutes to do the analysis. For the next round, they had 10 minutes. For the time after that, they had 5 minutes. So they were under a lot of pressure to make a lot of measurements in a very short period of time. When we came to look at the results, we judged the analytical performance on essentially 4 criteria. The analytical accuracy, how good was the team's answer compared to the actual value of creatinine, on the volume of sample that the teams needed to use in order to get the result, how quickly they obtained the result, and how many results they could get that were valid. So the total number of measurements that they could make. All those parameters were assessed, and the analytical performance was then judged upon those. And so, down. So the team that's awarded the Analytical Performance Prize is Biosensor from Leuven.
Okay, enough pictures. Thanks again. Let's move on. So we go on to the second award, the Creativity Award. And I would like to ask Dr. Jeroen Nieuwenhuis to present this award.
Good afternoon, everybody. It's a great pleasure to present the Creativity Award. And as most of you probably know, the creativity will be judged on 2 different aspects. The first aspect is focusing mainly on the technical domain. So here we look at the creativity in the technical approach that the teams took. And the second aspect that we judged is the creativity in the process on how to execute the project and how to come to the results that you presented yesterday. But if we look at the technology, and I think all of us have seen the presentation about an hour ago, there were many technical innovations that were used by actually all of the teams, I would say. And we've seen elements being used like nanotubes, we've seen MIMS, many teams used 3D printing to realize the prototypes. We've seen innovative assay formats, creative ways to do compensation, to go to a dynamic readout. We've seen microfluidic designs that were innovative. So I think from a technical point of view, we've seen quite some innovation from a number of the teams. If we look at the execution part and the creativity in the process, talking to the teams, we realized that many of them had some very similar experience in setting up and starting the project. It's difficult to form a multidisciplinary team, get everybody together, find the resources that you need. Some of them needed to raise funding, get to talk to the experts and get access to all the materials that are needed to make your prototypes. So I think there's been quite big challenges for all of the teams, but I think that also makes for a very rich experience. And I think the teams found very good solutions, because if we look at the projects as they were presented yesterday, I think we saw some very interesting presentations. If we now look at the scoring, we scored both of the aspects individually. So for each of the teams, we had a scoring on the technical part and on the creativity in the process. And I must say that when we look at the process, it was not too discriminating between all of the teams. But when we looked at the technology, mainly two teams stood out, particularly when we look at the measurement principle. We saw the team from Eindhoven that used a very innovative assay format to detect the creatinine by modifying the antibodies and coming to a competition assay. And we also saw the team from DTU that had a very brave and adventurous approach to come with a radical new concept. I think we weighed and scored all the parameters, we tallied them up, there was an Excel sheet, and after some computation we finally came to a winner for the Creativity Award. And the award for the creativity goes to the team Test from TU Eindhoven.
Mooi, dankjewel. And then we move on to the Translational Potential Award. Winnie Svensson will present this award.
Thank you. The Translational Award was just upon the medical applications and the industrialization and commercialization potential. Now, the race against winning this award was very close. We had two teams with 0.1 between them for the winning prize. But there are only to be one winner. And the winner was judged upon their analysis of the end user's need, that they were unique in having carried out this analysis, and the very, very clear plan of go-to-market. So the winner of the Translational Prize is Biosensor. Eindhoven.
Dank jullie wel. Oké, we zijn er bijna. Then you, the public, has decided, and the teams. And we saw some strategic voting, maybe from the teams against other teams, but okay, let's call that smart. And so we think it's an honor to ask Professor Menno Prins to present this award for you. Thank you.
Thank you. So the jury asked me to present this award, and I think one of the reasons it's the honor, but also the reason is that it's really deep into the philosophy of SensUS. We want to stimulate innovation in the field of biosensing by generating a strong community with universities, with companies, patient organizations, and with patient organizations and healthcare professionals. And interacting with the public and listening to the public is a key element in that. So therefore, I'm very glad to be able to award the Public Inspiration Award, to give the prize to the team that has shown to be able to inspire most the public, as you are here. I don't know the name in this envelope. It's the jury that has been filling it in, but I'm going to open it now. So the winner is... The winner of the Public Inspiration Award is Creasenza.
Okay, last big applause, Creasenza. Well, on behalf of the jury, I would like to thank the organization again for the support during this competition, also for the personal help from Joyce, Kim and I, and Lieke van Dommelen, and for having us involved in this wonderful event. And we're looking forward to another very great event next year. Thanks. Stop. We decided that it would be a nice idea to have all the teams on the floor again for a nice picture. Can you do that? Thanks.
Can I take? Yeah, the microphone is working. So I would like to use this moment to look with you, or to speak with you about the time 1.5 years ago. We had an idea. We had on a winterish Friday afternoon in January 2015, we had an idea to start something new. Something that could stimulate innovation in the field of biosensing. And as the idea grew, we had many questions and we had many, many moments of uncertainty. And I want to share 8 of those uncertainties with you. The first uncertainty, we know that it's very difficult to make a biosensor. And can teams of students really make a working biosensor in less than a year? Well, we have the answer today. Second question, students have very full education schedules. Would students be able to dedicate themselves to a project for a complete year in addition to the regular studies? The answer is yes. Would university staff members be willing to coach and host these students working on their SensUS project? Well, yes, and I see others also. Fourth question, funding is needed to set up a competition. So would TU Eindhoven and would companies be willing to truly support such a competition? Again, the answer is yes. And the aim of students is to involve patients and healthcare professionals. Would they be interested to work with us? Well, I think we've seen several examples expressed here on the podium where we say yes, it's very clear. So I would like to thank the TU, the TUE, and the companies for their support. And a couple of names that were not yet mentioned, the Kidney Foundation and Heart Foundation were mentioned, but also the Stichting Techniekpromotie, Sensor 100, and Cooperation WOW. Thank you very much for working with us. And now I'd like to give Luke the microphone.
I'm going to give a word of thanks to our jury for today. We're incredibly grateful for each and every member of the jury. I guess I'll stand over here. All right. For taking the time of your busy schedules to come here, especially from far away, to present. And for that, I would like some of my team members to present a token of our gratitude. And whilst they go, I'll just say a little bit more about how great you are. It's because of you that we have this. We've been able to give out these awards with such thoughtful and careful consideration for our team's work. And hopefully they're ready by now. Not just yet, but I can keep killing time. Yeah. filler. Okay, no. All right. So we have some lovely flowers, definitely. That's for sure. Yes. They're still on their way.
Yeah. Let's wait.
I think we just wait in silence. We can wait in silence. The anticipation is killing us. Okay. All right. And I think maybe an applause.
We would also like to thank the speakers very much for their great talks. Okay, while this is ongoing, I will present you the sixth uncertainty that we had to deal with. That is, with biosensor innovations, we want to reach and interact with the public. And our question really was, we all know the solar challenge and we all know the RoboCup, where it's either the cars running through the desert or it's robots playing soccer. So our question was, how can we make an international biosensor competition interesting to see and fun to watch? And so interesting for an audience like you. And seventh question on uncertainty. To set up an international competition is a massively complex endeavor. And the philosophy is made by students for students. And already Rogier made a great hand to the SensUS organization. So I would like to thank the 21 students of the SensUS organization, the students with whom I've been working the last 1.5 years. It's amazing how imaginative and creative you've been, how you have assumed responsibilities and worked together and to realize this event, which has lasted a couple of days, and today is the end of it. So I'd like to thank you very much again. I think, Luke, it's your turn.
All right. In the middle, I was told to stand by the good old Barry. I think there's a thank you in order for the real reason we're all here, or the reason this all exists, the founder and idea creator behind everything. We all know him as Menno Prins, but I want to say a little more. As being a chair and working so closely with you, I'm just ever so grateful for the leadership and the help you've given in every single student. And I think we've all grown, and I think this competition is amazing, and I'm so happy we all have been able to come along with you. So, thank you so much.
Oh, you can go.
There you go. And with that, back to you.
Okay, now we get to the end of it. The final question. That's the 8th question of uncertainties. And the 8th question marks the journey that we are all on. It's the question, can we make a competition like SensUS grow and make it really have an impact on society with results that help patients and doctors? And that's something, of course, we still have to prove. Geert-Jan very clearly explained how long it can take and how difficult it is to make something that really works in the hand of the end users. But we're on the journey, so I would like to announce what's going to happen next year. So what is the biomarker for SensUS 2017? Somebody already asked it. And I was very happy, Geert-Jan, that you mentioned as number 1, heart disease, cardiovascular. So the biomarker for next year will be NT-proBNP. And that is a key biomarker for diagnosing heart disease, in particular heart failure. And it's important for the diagnosis as well as the monitoring of heart failure. And I'm also very glad to tell you that SensUS will grow. This year we have 5 universities. Next year there will be 10 universities. And there will be, of course, the universities of this year that will continue, and 5 more from countries including Switzerland, Egypt, the United States of America, and Scotland. So we very much look forward to a great SensUS 2017. And I would like to thank you for all coming. What are you laughing about? I would like to thank you for coming today, and I wish you a very good remainder of the weekend. The master of ceremonies of today, Barry Fitzgerald. I think we could not have made a better choice. Actually, the students make the choice. They approached Barry, and actually, I saw Barry today for the first time. Yeah. And so I would like to congratulate the students with this great choice. Come, look. And I would want to give Barry the floor. Thank you so much.
Thank you very much. Thank you, Luke. Thank you. No problem.
Sorry for the delay.
No problem.
Thank you very much.